Hello everybody. Today I want to talk about a different subject which has not to that extent covered before in any of the technologies. The general subject has been discussed and experimentations have been conducted based on that. However, it has not been pointed out the importance of it. Nikola Tesla did develop his technologies which are literally based on static electricity, and it defines the propagation of waves which are created via Tesla coils. And as radio engineers, we all know, or you all know, that your world is based on the electromagnetic wave. That is the waves which we all know today, how our radio works, how our communication system works, how broadcast works. Literally everything is based on electromagnetic waves, which is a retarded wave. That means it is always slower than the speed of light. And there's another wave which is by many not accepted to be existing. However, it has been proven more than once that it exists, and it exists in the nature all over the place. And I want to conduct today some experiments to show you that it exists and what kind of application we can use to benefit from it. Here we have our normal setup. Well, you will see I have a little additional application or tool here in between. It's called a spectrum analyzer. It's an analog tool. It's not very precise. However, it gives me some indications. Goes up to 1 gigahertz, or can measure up to microwave wavelengths and so on. I have at the moment tuned the TMT to its main frequency, so it's 181 kilohertz. So the first peak is here at 180. It should point out 0.1. So that is at the moment at a division at 0.2. So that means each division here replicates 200 kilocycle, and we have 10 of them, so there's 2 megacycle literally of them board. What you can see, have sine wave applied. This little setup here will be my proof case. There are 2 metal boxes, cake boxes to be precise, and we have a little radio here. So what I'm supposed to do with this radio, I show you electromagnetic waves, and I think you all know what it means. If we use a Faraday cage and put a radio inside a Faraday cage, we will not get any reception anymore. Why is that? The Faraday cage is based on a construction like a mesh, or it can be a container, a metal container. What it does, the mesh structure has a length, and the transverse magnetic field propagation has a wavelength. So when the mesh is smaller than the wavelength of the transverse magnetic radiation, the field is shielded. So good so far. If you have a metal container, the mesh becomes all of a sudden a width of the molecule or atom length. That means in order to penetrate metal container, I would have to use a frequency on a subatomic level if we propagate via transverse magnetic radiation. So far so good. I think the setup of the Tesla coil, we have seen that before. Let's now start with showing you what it means to put the system, a radio here from a radio transmitter, receiving a broadcast from a radio station, what it means to put it in a shielded environment, or so-called Faraday cage. So here's the radio, it's now tuned to a radio station. I put it inside the container. You can hear already the reception gets lower and lower. And when I close the lid now, sound is gone. You hear only static. Now reception is available again. Of course we do this one, and we're gonna do that shielded, so that is so-called a nested Faraday cage. A nested Faraday cage is literally a Faraday cage inside a Faraday cage. To make it a little bit more tough, put it here and put this one on top. There is no reception anymore, so this radio is dead. There is no way you can receive any radio signal. Now, is there a system available which allows you, under that condition, to receive a radio signal? The answer is yes, of course there is. A far superior system which can transmit through the ground, which can go to concrete, which can be inside a Faraday cage. It does not matter. It penetrates at all. And why is that? So I'm talking about so-called scalar waves. I'm talking about longitudinal waves. And what has not been defined so far is there have been a lot of videos around that subject. Eric Dollard, you'll find on my website a couple of videos from Eric Dollard where he explains that with a rope, with a piece of rope, when you pull that, there's also an explanation. If you look at a tsunami wave is literally a longitudinal wave. So if you look at our solenoid coil, we have the electromagnetic propagation, which is a wave which, on the water, it was explained, is going up, and then you have the magnetic wave which goes 90 degrees lagging in the same direction. So you have literally 90 degree opposite phase. You have electric and magnetic or current running. Now there's a third component, and the third component is the scalar wave, which literally runs inside the solenoid coil from the beginning to the end, forward and backward. It is a so-called pressure wave. So it runs from here to here. It literally pushes out on both sides, and that is actually outside our, that happens outside our space, because the propagation is not transverse, it is longitudinal. There's literally a point reference which is so sharp and so detailed that anything else cannot compare to it, like laser beams or whatever you want to call it. Nothing can be as precise as that, and because it's not transverse transmitted, there is no retard part of propagation. I'm talking about the speed. I can prove that as well. We will do some application to show that. So the propagation of transverse magnetic fields, as we all know, is below the speed of light, but because of the longitudinal wave and a different wave, because it doesn't need any time to reach from the beginning to the end, it is faster than the constant, the speed of light. And I have to refer here to Professor Wheatstone. That is pi over 2 times c. That's 290,000 miles per second. So coming to the main subject, why am I doing that here? The most important part here is, if we want to have a communication system, and I have been reminded by forum members from Eric Dollard's forums that the first thing we should do is not to focus really on wireless transmission on energy. We should focus on communication, because if we change communication, the logical consequence would be energy. To do that kind of systems, or to apply this kind of system to communication, is very simple. I will not go to the subject around that. That will be part of my professional part of research and development to deal with it. But what I can show you is how we can define that it's working. So let's go back to our example here with our Faraday cage. So before we move on to our demonstration how we can propagate electric waves while scalar waveform and be independent. Let me show you another example which I can demonstrate to you here quite nicely now. So at the moment we have a sine wave actually running through. So that is without any filters, that is what you have at the moment. Of course, when I touch it a bit, it will get a little bit more. And you see also here's a form here on the scope. Now let me change that to a square wave. Look at that. Now we get an extremely strong signal and beautiful harmonics. All the octaves. Look at that. That's tremendous. Now if I change it back to sine wave, gone. So that should now give you an indication why we have to use pulsed waves. There's much more energy in the system. Okay, let's go back. Now let's go to the frequency modulation. I have added now frequency modulation. As you can see here, looks very nice on the spectrum analyzer. So the frequency, of course, the modulation changed, as you can see here. It's much higher, and also the octave. So I have set the radio at the moment to 181, can say to 182. Now my radio's here. Let me put this up in the plastic bag. Now let's go to 187. Let's see. Okay, let's put it in here. Let's put this one in here. Close the Faraday cage. Makes still a hell of a noise. Put it in here. Makes still a hell of a noise. And I can tell you, I can go out in the garden now. I can walk away from the house and I still receive that signal. And that is not grounded. I mean, I take it here in my hand and walk away and would still have that signal received very strongly. So that is one indication. Let's have a look what else we can do. I'm now in my garden here. At the end of my garden, about 20 meters away. I can still hear the signal. You can hear the signal. It's a bit noisy out here, but the signal is almost as strong as it was inside the garage. And please bear in mind, this is only done via a signal generator. There is no amplification here on this Tesla coil, just a simple signal generator. That should give you some indication how powerful that is. So what we can do here, we can apply, you literally can use any radio technology today on the market and you can adapt it on a transmitting and on the receiving side using Tesla technologies, and you literally transmit everything what you normally would do transverse. You just exchange and transmit it scalar. Thank you.